Hello students, welcome to our Asian International School online tutorial class, and today in this class we will learn how to draw images in case of concave lens. Previously we have done convex lens, now we will do concave lens. Now we will place the object same as we placed in concave lens. So let's start. So at first, in the first case we will place the object at infinity. Now object is at infinity means light ray coming parallel. All the light ray, the beam of light coming, it's parallel to themselves. Also we will take the light as parallel to principal axis. This is the first case. Okay, so the two rays which are parallel to principal axis will refract. Now we know they will refract away from the principal axis. Since it's a concave lens, it diverges away, the light diverges away after the refraction. Now while we draw it, we have to keep in mind that the light rays, when they diverge away, the diverged light should be pointed towards the focus, the f1, this one. That means we will align the scale such that the diverged ray will be pointed, will be drawn from this f1. If I show you that, it will look like this. Okay, similarly for this ray, this will be the picture. Now the thin line, the narrow line, this thin line is the virtual line. So now I have to draw the refracted ray with a solid line. I will show you that also, this one. Now in computer I am using this line. Now what you will do while you will be drawing in your copy, then you will use a dotted line to show the virtual line. This virtual line which I am showing as a thin line, you will show it as a dotted line. Okay, and when you will align the scale from this point to this point, then you will draw a dotted line up to here, then a solid line from here onwards. Okay, understood? That's how you will show the virtual line. Same in this case also, in this line also you will place the scale along this point and this point, then you will draw a dotted line up to from this point up to here, and then from this point you will draw a solid line. That's how you will be able to show the refracted ray. Now obviously the drawing, if you draw once or twice, after that you will see this drawing is very easy, absolutely easy to draw these virtual lines for this particular concave lens. Okay, so this is how the first drawing is done. Now the characteristics of this image, we can understand that it's a virtual image, definitely, because virtual lines are meeting at a point, so it's a virtual image and they're meeting at a point. That means the image is a point image, point size image. Also it is at the side of the object. From the lens, it is at the side of the object is at left side of the lens, and the image is also at the left side of the lens. Okay, so this is the first case we have done. Now let's go to the second one. Alright, now in the second one we will place the object beyond C. So let me place the object first. This is our object. Now as always, first line parallel to principal axis, second line through the optical center. There will be no deviation for this line because it is passing through the optical center. Give the arrows. Okay, now once again we will draw the virtual line first. And from this point we will draw the solid. Just a minute. Okay, now from this one we will draw the, all right, Now give the arrows. So we can say this is the light which was parallel to principal axis, which gone like this, and if we trace back, or if we draw the virtual line for this refracted ray, it will meet at focus f1. And this is the solid line for the incident ray for the second one, the second incident ray, and passing through the optical center and going undeviated. Now we can see here is a meeting point. This is the meeting point of a virtual and a real line. This is the real line and this is the virtual line. It is a meeting point. So there will be one image formed here. So this will be the image point for this object, for particularly this object. So let me draw the image. Okay, so this is the image. I hope you have understood this. So it's a simple drawing. Once or twice you practice, these all drawings will be absolutely easy for you. Okay, now for the characteristics of this image, you can see it's a virtual image, because virtual line creating this image, so it's a virtual image, and it's a diminished one. It's smaller than the object, and it's placed between the optical center and the focus. Also it is upright, it's standing up, the object is standing up, image is also standing up. So it's a non-inverted, okay, it's a upright image, it's a erect image and a virtual one. Okay, so let's go to the next one. In this case, now we will place the object at center of curvature here. Okay, so now I will try to draw a little faster now, because we have done this so many times, so it must be very easy for us to understand now. Done. So once again you see, this is first incident ray, this is second incident ray, this is first refracted ray, this is second refracted ray. So once again one virtual line, this is the virtual line, the thin line is the virtual line, and this the thicker line, which is the real line for the second incident ray. They are meeting at this point, so image will be at this point. If I draw the image, this will be the image. So once again the similarly just like the previous one, the image is a virtual one, it's a smaller, diminished, it's upright, okay, non-inverted, there is no inversion here. So you can see the previous drawing and this drawing, both the cases you have the image same. The position is also between the focus and the optical center, size and nature is also same. Now here is one point, one thing I have to tell you. For concave lens, we have this kind of images formed in every time. Unless your object is at infinity, then you will get a point size image, and wherever you place the object, your image will always be like this. It is always diminished, always between focus and the optical center, and it is always virtual. Let me show you one more. Now in this case I will place the object between the center of between the optical center and the focus. Let me place it here. Now let's see what will happen in this case. Done. The thinner line, as always, it's the virtual line. Now you can see this virtual line and this real line meeting at this point. This is the meeting point. This is the meeting point for this virtual line and this solid line. Now if I draw the lines, if I draw the arrows, to complete my drawing. So you can see the image will form here. So if I draw the image now, okay, so this is the image. So this is the object, this is the image. So even if the object is placed between the focus and the optical center, the image is still coming within the focus and optical center. That is exactly, I told you just before, that wherever you place the object, if it is a finite size object, if it is placed at a finite distance from a concave lens, you get the image always same. It is a virtual one, it is erect, it is non-inverted, it is upright, and it's smaller in size. Also it is placed between focus and the optical center. So technically we can understand here one thing very clearly, that concave lens drawings are easy, because wherever will be the object placed, the image will be always like this. Every cases you will get this kind of image, unless the object is at infinity, then you get a point size one, but any other cases you get same kind of images. I will not draw anymore. I think you have understood, and you please try the other one that I have not drawn in concave lens. I have not placed the object between C and F. I have not placed it at F. You please try it and check whether all the cases are giving you same result or not. That's it for today's video. We'll see you in the next one. Thank you.